August 27th. Welcome home, says that lawnmower outside. Grab a coffee and let's get smarter together. Just mentioning geometry might cause you to break out in cold sweat. Nostalgia has not yet romanticized rulers and compasses for you. Be brave, my friend. This will be more of a journey into the history of the subject for the sake of our dear spherical cow. The foundations for geometry were laid, probably by women, far, far in the past, because you simply cannot weave, sew or potter without some understanding of, for example, the angles in a square or the length of the circumference of a circle. It was Euclid, though, to write down what we know and what we know today as Euclidean geometry. The kind of tabletop geometry that can all be reduced to 2D thinking. You can unfold any cube or whatever so its sides form a pattern in 2D, and that we encounter in 3D model, the 3D model of our world our mind produces for us. Just as an aside, because, well, I can't stop myself from being an insufferable know-it-all. As Poverty Point in Louisiana demonstrates, the indigenous people of the Americas had their own version of geometry that was not Euclidean at all, that they shared across the continent. What begs, of course, the question, how many other ways to think about space have been there that European conquer has eradicated? Anyways, back to Euclidean geometry. One of the rules Euclid stipulated in his work was that the distance between parallel lines remains the same into infinity. Imagine a line with two lines sticking out perpendicularly, not like I just chose, they are sticking out perpendicularly in a right angle. According to Euclid, they never meet. Well, now imagine the same two lines sticking out perpendicularly from the equator of a sphere. They will, of course, meet at the poles of a sphere, like the longitude lines on Earth in geography. Everyone knew that. Just as everyone knew that the angles of a triangle drawn on the surface of a sphere added up to more than 180 degrees, or that the circumference of a circle drawn on a sphere was smaller than 2πr. These are all things that shouldn't happen according to Euclid. But for something like 2,000 years, we just rolled with it. No one considered creating a whole new branch of geometry just for a sphere. Who knows? What's a sphere anyway? Well, it's a little weird. Has to go. Anyway, along came Lobachevsky and Boole and thought to themselves, if it's possible that parallel lines curve to meet like on a sphere, who says they can't diverge? Oh. This happens if your two-dimensional plane itself is curved to resemble almost a saddle or a Pringles potato chip. But not quite. Because, and that will be important, an exact hyperbolic plane exists only in our mind. Other than a sphere, we can't recreate such a space as a two-dimensional surface embedded in the space where we live. At least not so we can see it with our eyes and the model that is created in our head from the world says, yes, that's a hyperbolic space. The closest we get are saddles and Pringle ships. That's important because it requires a huge shift in the way we think about space. The way our mind suggests to us is that we put ourselves apart from the, let's call it object, and observe its extrinsic properties that it inherits from being embedded in a larger space. Computer mouse. This computer mouse looks like a three-dimensional computer mouse because it is embedded in the space around it, and the space around it is a 3D space, at least in our mind. Hyperbolic planes don't exist in any larger space. It's not like a computer mouse. It's just like the universe. So we can't do that. We can't look at them from the outside and draw conclusions from embedding it in a larger space. We must study its intrinsic geometrical properties by understanding ourselves as a part of it. Here's an example that might make the difference clear. When we look at an empty toilet paper roll, we recognize it as a cylinder, right? That's the extrinsic impression of an observer who lives in a 3D space thanks to their minds, our own minds. Now, imagine yourself being a part of a cardboard and walking some more. The outside observer would watch you walk circles around the cylinder. But you, being part of a cardboard, perceive it as a flat surface. That's the intrinsic view. The quantum space we live in resembles hyperbolic space in the aspect that we can't observe it. It's there, all around us. But we can't observe it because we don't observe reality. We just observe the model our mind creates for us from some information it gets from the physical universe. All we can do, therefore, for the quantum space is study it while we accept that we are a part of it. Two things to take from the story. One, humans knew for approximately, and that's mind-blowing, it blows my mind just, 2,000 years that Euclidean geometry wasn't the whole story. Instead of exploring what was missing, we rather tried to make it work somehow anyway. Forget about the sphere. Euclid is right, not the sphere. Well, this reminds me of all the proof we got that neither Hobbes nor Rousseau were right with their assumptions about the human nature. Nevertheless, we put all our energy and literally sweat, blood, tears, and human lives into proving especially Hobbes right. And two, the model of a world that our mind produces mostly by using creativity to fill out the blanks in the fishnet that the facts we get from the outside represent, doesn't only suggest to us that we are an observer when it comes to shapes in space. Since we identify with the self that the mind cuts out of a tapestry of a generated model, it's our constant point of view. This distance between us and the physical universe does not exist. The physical universe is one large wave function. We are just a part of it. Vibrations of energy, and we are a tiny part of it. Each one of us. We need to start with an intrinsic view to learn the truth about us. The spherical cow that leaves the complications that is the mind with its eccentric viewpoint out of it and explore from there. Maybe we even rediscover our sixth sense, the sense for energies, and I believe very firmly that our ancestors had that when they looked at waves and realized, well, some 1,000 miles over there is Australia, let's go. Well, this sixth sense maybe we rediscovered on our path. Turn your curiosity back on. Explore. Make a habit out of exploring. Let's turn exploring into the norm again. For all. Not just for the people who call themselves scientists. Like, comment, share, and follow, lest you miss a single opportunity to improve yourself and society. Once you do, we'll meet again at the coffee pot.